We're going to look today at how we can take data, mathematical information, and arrange it so that it's easier to understand and that we can draw inferences from it. We can be able to predict what might be going on based on this information. And in fact, in computer science, in some of those classes I teach, we distinguish between data, which is just raw numbers, and then information, which by analyzing the data, by manipulating it one way or another, allows us to use those batches of numbers or just batches of random facts in a way that we can draw inferences from them, make predictions, and use them to our benefit. We're going to be looking at how we can process data to get information out of it, where information is, well, something you can use to do something with, to make predictions, to do planning, and so forth. We're going to start with something that you're probably familiar with, although maybe not when it's called this, the arithmetic and weighted mean. And what we're really talking about is the good old average, which in mathematical terms is called the arithmetic mean. The definition for the average, which is often written as a variable with a bar over it, is the sum of all the numbers you have divided by how many numbers there are. For example, and again, in school, you're more or less dealing with grades, and I certainly hope those are your grades in Math 86. You take the grades, for example, you got a 90, a 95, and a 100 in your take-home exams, and since there are three numbers, 90, 95, and 100, you divide by 3. Let's look at some examples. In this case, if I do this calculation, the average grade is 95, which in my class would certainly assure you of an A. Here are some test scores. These might be a tiny bit more realistic. I hope not. I hope you get the high grades. But suppose we have 4 grades, an 84, a 92, a 94, and an 86. I add them up to get the total. Then I notice that there are 4 tests. The average then equals the sum of all of those grades divided by the number of grades. When I work this out, it works out very nicely, even if you have to do it at long division. I find that the average, or the arithmetic mean in this case, is equal to 89. Your average of those 4 grades is 89. Another place that averages come in handy are figuring out whether or not a house for sale in a particular neighborhood is reasonable. And to do that, real estate agents and people shopping for houses often look at the average house price in a neighborhood. And for example, if you have a house that's $500,000 and all of the other houses in the neighborhood average out to $100,000, that would tend to make the price that you would ask for your house a little bit less, because since all the houses around yours aren't worth as much, it would tend to depreciate the price of your property too. Calculating the average house price in a neighborhood then will help you to decide how to price your own house. Here are 5 house prices, and we're going to take the average. The first thing we need to do is add all of them up. Then we need to know how many there are. In this case, there are 5, so that the average would be 480,000 divided by 5. If I do the math again, fortunately I picked an example where it works out very nicely. And I can say then the average home price for this particular neighborhood is $96,000. If I want to sell my $500,000 house that I've put all this money into, I may not get everything I want out of it, because all the houses around mine would be relatively not quite as nice. Let's look at another problem that uses averages. Mary got her grade report in the mail. It said that her Math 86 grade, why did I keep picking that example, was 90%, which means she would probably get an A. She knew that out of 5 exams, she got an 84, 92, 94, and an 86 on the first 4, but she didn't know the grade on her 5th exam. And we would like to know what that was. Here's the information. Her average was 90. We're given 4 grades, 84, 92, 94, and 86, but she doesn't know the grade on the 5th exam that went into making that 90 average. What we're asked for is, what was the 5th exam grade? We're given these things. The average was 90, and 4 out of the 5 exams had those grades. What we'd like is the 5th exam grade. What we need to do here is to use the formula as we've given it for average and put in an X, meaning an unknown for that exam, where we would normally have the 5th exam. Now this gives us an equation that we can solve for the unknown X, which is the unknown exam grade. But you see, I use the formula for the average, and I'm given that the average is 90. It's the sum of all of the individual numbers divided by the number of numbers. Let's do the math here. First, I add those 4 up, then I include the X. I divide that by 5. Let's simplify that. The 4 numbers added together give me 356 plus X divided by 5 is equal to 90 over 1. I've seen this situation before, and I know that I can get rid of the fractions by cross-multiplying exactly the same way I did when I was dealing with proportions. When I do this, I come out with this equation. 356 plus X times 1 is 356 plus X. 5 times 90 is 450. Then, as I have done before a billion times in the past, I subtract the same thing from both sides of that equation to isolate X. When I do that, I find I've solved for X, and the last grade was X is equal to 94. So if we have 84, 92, 94, 86, and 94, that will yield an average grade of 90. Here's one that is in the same vein, but perhaps a little bit more interesting. The average of 10 students' test scores was 69. 3 of the students got an 80, 60, and a 40. 3 more scored 90 each, and 2 more scored 50 each. Then we're given the information that the other 2 students received the same score, and we'd like to know what that score that the other 2 students received was. Here's the information. 10 students, test score 69 average, so on and so forth. We'll review it here. We have 10 students, average was 69. 3 of them got an 80, 60, and 40. 3 of them got a 90. 2 of them got a 50, and 2 of them got the same score. We don't know what that is, and we want to know what that is. Again, I can write out this specifically. I'm given that there were 10 students. There is the 80, 60, and 40. There are the 3 90s. There are the 2 50s, and there are the 2 the sames, and I'm going to call them by the unknown S. Since there were a total of 10 students, I divide that by 10 to get the average, and it says that the average is 69. Let me do the math. I get 550 plus 2s over 10 is equal to 69. When I add up all the numbers I have, s plus s is 2s. In order to clear that, I can multiply both sides by 10 in order to solve for that original equation. When I do that and do the math, I get 550 plus 2s is equal to 690. Take a guess my next step. Right, I subtract 550 from both sides of that to isolate the 2s. I get 2s is equal to 140. I could divide both sides by 2 here, but if twice s is 140, what is 1s? 140 over 2, s is equal to 70. I get here that the two other grades were 70. I could, of course, go back and check this if I wanted to by putting 70 in there, redoing the average, and making sure that it came out to 69 it was given originally in the problem. Let's look at something interesting. Here are two lists of 6 numbers, both of which, when I try, I get an average of 50. But there's something wildly different between the two numbers. The first list, I have a spread of everything from 10 to 90. In the second list, I have a much lesser spread. The numbers are grouped together much more closely. We need also, in addition to talking about the average itself, work out ways of indicating, when you're looking at an average, just how good the information is. For example, if I were looking at temperatures and using measuring equipment, if I had the first list, I would assume that the measuring equipment is kind of crummy because things vary all over the place. On the other hand, it looks like with the second list, the one on the right, the measuring equipment might be a lot better because even though I get the same average overall, I have much less variance. And if I were running an experiment, since the information tends to be much more constant, say I was measuring a temperature, I would tend to trust that more. There are also ways of looking at how much something varies. We're not going to deal with it here, but if you take an average, you can use a statistic called the standard deviation to talk about how good the spread of data is. The bigger the standard deviation is, the bigger the spread of numbers is, and possibly the less reliable the information is. Another thing we can talk about are curves like this called Gaussians. This indicates the probability of the numbers, where the center of the Gaussian, the highest point, is the average. When the information is very good, you tend to get a very sharp Gaussian curve. When the information isn't as good and things are more spread out, the curve is flatter. And there's an interesting relationship between the Gaussian and the standard deviation. And incidentally, when they talk about grading on a curve, this is what they mean. If you have a large number of grades and look at the number of students versus the grade, it tends to fall into a curve like that. And typically, the center of the curve would be considered a C. One standard deviation on either side is 34%, or if you go both sides, 68% would get a C, and so on and so forth. And off to the right would be the high grades, off to the left would be the lower grades of the center. I'm just bringing this up. I'm not going to ask you to do any calculations based on it. I just thought it would be interesting to show you. Now let's look at the idea of a weighted mean and deal with grade point averages. Here are some credit hours. For example, math is 3 credit hours, chemistry is 4, and music is 2. If you get grades for these particular classes, and this is a school where you can get A minuses, A pluses that give you things about halfway to make the calculation a little bit more interesting, you see that since you got a B in music, that shouldn't be worth as much in terms of your grade point average as the A you got in chemistry, because the music was only a 2 credit hour class and the chemistry was a 4 credit class. We need to weight that so that you get more credit for the chemistry than you do for the music. What we do is multiply the number of credit hours by the grade to give you the grade points, so that your 3.7 for your 4 credit chemistry class gives you more grade points than your 3.7 for the Math 86 class, or even more than your 3.0 for the music class. Then we calculate that, and we add it up and divide by the total number of credit hours to get your GPA, or grade point average. We take the total grade points divided by the total credit hours to calculate the GPA. That's an example of a weighted average. And what we're really saying is you take the 3.7 from math 3 times, the 3.7 from chemistry 4 times, and the 3.0 from music 2 times. And if you add all those together, you see there are 9 different items there, so you divide by 9. In effect, you're giving each of those 3 grades different strengths or different importances. There's the 3 for math, there's the 4 for chemistry, there are the 2 for music. Let's look at another example for finding a GPA, which is a really good example of a weighted average, a weighted mean. We have 3 classes, in this case 4 classes, I'm sorry, I can't count here, maybe I should take Math 86, with different credit hours. And here are the grades. And remember, to get the grade points, I weight the grade by the credit hours. There are the grade points, I add those up. Next, I do the math, I take the total grade points, which is the grade average, if you will, weighted by the credit hours, add those up, and divide by the total number of credit hours, in this case, to get a grade point average of 3.46. B plus, not too bad. Let me just review here the rule for the weighted average and throw in something that really spooks people and isn't a big deal if you understand what it means. When you deal with some mathematical quantities that means take a sum of, you'll see that represented by this funny looking thing, and unless you were in a fraternity or sorority or taking a bunch of physics classes, you may not know what it is. That's the Greek letter sigma, and it's used in mathematics to mean add things up. Here we're using it to take the sum of the weight times the quantity divided by the sum of the weights. When you see that funny symbol, all it means is add up the things in the list. Take the sum of the things. Let's now move along to other statistical examples, things called the median and the mode, and look at them and understand why they might be useful. First of all, the median is the number in the middle. If you have an odd set of numbers, there is a middle. If you have an even set, you have to average the 2 center ones. Let's see what it is and why it could be useful. Here's why it's useful. Sometimes, if you're looking at an average and you have things in the average that are way bigger than the other numbers in the list, it'll tend to skew the list toward the high side. When you're talking about an average household, really what you're talking about is more than the arithmetic average, what's in the middle. And that's what the median helps you to find out. For example, here are a bunch of salaries for the Worldwide Widget Company. And what we would like to know is, what is the salary of the worker in the middle? We can say average, but here's the point. There are some people in that who make very high salaries, and that doesn't reflect where you are in the total range of salaries, because that $100,000 salary a manager might make, the $55,000 salaries an engineer might make, doesn't represent what the worker gets. What we really want is what's the middle thing, halfway between the most and the least. If we find that, that number is called the median. Here are some other examples. first of all, to find the median in a set of numbers, you arrange the numbers from the smallest to the largest, and you locate the middle number. If you have an even set of numbers, you take the average of the center two to get what the middle of the list would be. Here are some house prices. In a neighborhood, we have $70,000, $80,000, and then there's a $1 million house. If I look at the average by adding them all up and then dividing by 5, I see that the average price is $260,400. But again, that may not be an accurate representation if you want to tell someone what houses commonly are in the neighborhood. So you line them up and you check the one in the center, being that's the center of the list, that's the median. So you see that's a truer representation than the average, because that $1 million house sitting in the middle of the neighborhood skews the prices the wrong way and could give you a false idea of what to expect when you go house shopping. Suppose you shop around by reading the paper and looking at oil change prices around Tucson. What you may find is a spread of prices like this, and what you would like to know is what the median price is. That's the price in the middle. Here we have an even number, so there is nothing truly in the middle. In order to calculate the median in this case, we need to take the average of 12 and 16, which we do here. 12 plus 16 is 28 divided by 2, so in this case our median price would be $14. When you have an even number, there's no number in the center. It's necessary then to find the number in the center to average out those two middle numbers, as I've done here. Here's another example for finding medians. Here are a bunch of teachers' salaries, and the first thing you need to do, notice these are 45,000, 28,500, 27,500. After we need to line these up in order, in decreasing order, or increasing order. So I've gone now from 27 to 45, and this helps me to locate the middle. Again, here I have 6. I need to find the average between the 28,500 and the 35. I have to then average those two out. In this case, the median is 29,500, which sits halfway between the 28,500 and the 30,500. In order to do this, I took the numbers written pretty much in random order. Then I ordered them from lowest to highest or highest to lowest, just so that they're in a string so you can spot where the center is. And then, since I had an even number, I took the average. The mode is a different statistic. Here, the mode in a list of numbers is the number that occurs most often. For example, here's the students in a class or in a school. It's a very small school, maybe the one like I went to, and I look for the numbers that occur the most. As I list them, I see that there are 3 6s. The number that occurs the most here, which is the mode of the ages, is 6. To find the mode of a set of numbers, here's the rule. You count the number of repetitions of each number, and the number with the most repetitions is the mode. If there's no repetitions, or there's no mode. If there's a tie, you have 2 modes or 3 modes, and so forth. For example, let's look at a restaurant. Here are entree prices. $9, $8.50, $7.50, and so forth. What's the mode here? I see that there are 3 entrees that are $8.50. Therefore, I say that the mode for this example is $8.50. Here's another one. round-trip airfare from Tucson to Atlanta. I look at those and ask, what's repeated? I see I have two $250s and two $220 tickets. My mode there is $220 and $250. One more example. Here are some score results. I look there and I don't see any numbers that are repeated. For this case, what's the mode? Since there are no repetitions, I would say there's no mode for this set of data. That concludes pretty much everything I wanted to tell you right now about organizing information and deriving things that we can use from the data, deriving information from the data mathematically. Statistics is a very, very deep and it can get very complex topic. We're just skimming the surface right now, but it can be very useful if you're doing research, when you want to know what sorts of conclusions you can draw from sets of numbers.